Look up. Our sun, that glorious life-giving furnace, is already dying. In a mere 5 billion years, it will swell, then shrivel, a cosmic ember. But that's just the overture. Every star you see, every blazing supernova, every distant galaxy is on an unstoppable march towards oblivion. Trillions upon trillions of years from now, the last red dwarf will sputter out, its nuclear fires finally extinguished. The universe will plunge into an unimaginable, suffocating darkness. No light, no heat, just an endless, featureless void. Colder than anything you can possibly conceive. This isn't just the end of stars, it's the death of light itself. Our universe, a place currently screaming with energy, will become a silent, frozen tomb. But what if aeons after that final ember fades, after timescales that make the current age of the cosmos look like a fleeting breath, something impossible begins to stir in the ultimate cold? What if, in a universe that has been dead for more time than it has ever been alive, the very fabric of reality somehow ignites the universe's final, most desperate, and most terrifying stars? The universe began with a bang, yes, but quickly it orchestrated a grand, blazing overture. For billions of years, cosmic gas clouds collapsed, ignited, and screamed into existence. These were the first stars, colossal titans that lived fast and died young, detonating in supernovas that seeded the cosmos with the heavy elements of life. They were the universe's first furious act, a spectacular, violent beginning. Then came the main sequence, the glorious long-running performance that defined our cosmic epic. Billions upon billions of suns like our own settled into a steady nuclear rhythm. They fused hydrogen into helium, burning with a stable, predictable light for billions of years. These are the stars that paint our night sky, the cosmic beacons that forge planets and cradle life. This is the age of gold, the vibrant middle act of the universe's stellar drama. But even gold tarnishes. Even the most stoic performers must exit the stage. Massive stars, those cosmic gladiators, tear themselves apart in cataclysmic supernova, leaving behind the crushing singularities of black holes or the hyperdense cores of neutron stars. These aren't stars anymore. They're gravitational scars, silent, devouring specters that will persist for aeons, slowly, imperceptibly, evaporating. And our sun? It's destined for a quieter, yet equally terminal fate. It will shed its outer layers, becoming a white dwarf, a hot, dense cinder, a cosmic ember slowly, agonizingly cooling. Picture a dying campfire, its last sparks fading over days. Now stretch that out for quadrillions of years. These are the universe's mausoleums of light, shrinking, dimming, becoming ghosts of their former glory. But the true stalwarts, the ultimate procrastinators of death, are the red dwarfs. These tiny faint stars sip their fuel with such excruciating slowness that their lifespans stretch into the trillions of years. Our sun will be a frozen corpse for aeons before the oldest red dwarf even begins to falter. They are the universe's last stubborn candles, flickering against an ever-deepening gloom. Yet, even they are finite. Eventually, inevitably, the last, most ancient red dwarf will exhaust its fuel, its light winking out, not with a bang, but with an almost imperceptible sigh. And then, the universe will truly fall silent. The last nuclear furnace will be cold. The last photon from a living star will have traversed the void. What remains will be a scattering of dark, dense remnants, black holes, neutron stars, and the frigid husks of white and brown dwarfs, drifting through a cosmic night that stretches beyond comprehension. An age of absolute darkness descends, a void so profound that the very concept of light will become an ancient forgotten memory. So here we are. The cosmic stage is dark. The final act of stellar ignition has played out. The universe, once a symphony of light and heat, is now a silent, unimaginably cold expanse. Matter, once organized into blazing suns, is now scattered as inert, frozen remnants. Black holes are slowly evaporating, neutron stars are cooling, and white dwarfs are mere cosmic ash. The temperature plummets towards absolute zero. Energy gradients, the very drivers of change, flatten out into a uniform, eternal stillness. How could anything ever ignite again in such a profound, ultimate chill? This is where the universe reveals its most audacious secret, a paradox so mind-bending, it shatters our classical understanding of reality. Quantum tunneling. Imagine a ball at the bottom of a hill. To get over the hill, it needs energy to roll up and over. That's classical physics. But in the quantum realm, the ball can simply appear on the other side of the hill without having the energy to get over it. It's like walking through a solid wall or winning the lottery a trillion times in a row every second for an eternity. It's an almost impossibly rare event, a statistical ghost. But given enough time, and oh, does the future universe have time, the impossible becomes inevitable. In these frigid, dead white dwarfs, the atomic nuclei, mostly helium and carbon, are locked in a crystalline lattice, packed tight but utterly inert. There's no heat, no pressure, nothing to overcome the electrostatic repulsion that normally keeps them apart. No conventional fusion can occur, but the universe has an almost infinite patience, and quantum mechanics has an infinite statistical lottery. Over timescales that defy human comprehension, we're talking 10 to the power of 1/500 years, a number so vast it makes the age of the universe look like a nanosecond. The nuclei in these dead stars will, against all odds, quantum tunnel through their repulsive barriers. Think of it, 2 atomic nuclei, frozen solid, not moving, not vibrating, yet through a cosmic whisper of quantum probability, they pop into existence close enough for the strong nuclear force to bind them. This isn't the raging inferno of stellar fusion. It's cold fusion, an agonizingly slow, almost imperceptible process. It's like watching paint dry, but the paint is made of atoms, and it's drying over more time than the universe will ever see. This isn't a theory from a science fiction novel. It's a chilling prediction of quantum mechanics when applied to the far, far future. It reveals a universe so patient, so utterly vast in its temporal extent, that even the most improbable events become certainties. This quantum whisper, this phantom process, will begin to convert the light elements in these dead stars, the scattered remnants of once blazing suns, into heavier elements. It's a slow, agonizing alchemy of the deep void, and the ultimate product of this impossible, cold alchemy, iron-56. Why iron? Because iron-56 has the lowest mass per nucleon of all atomic nuclei. It's the ultimate endpoint of both fusion and fission. Fusing lighter elements into iron releases energy. Splitting heavier elements into iron also releases energy. Iron is the cosmic dead end, the most stable atomic configuration. So, over these unfathomable eons, these dying white dwarfs will slowly, infinitesimally, transform their very essence into pure, solid iron. This process is so incredibly slow that the energy released is minuscule, almost undetectable, but it's enough, just enough to ever so slightly warm these cosmic husks above absolute zero, just enough to create a faint, almost imperceptible glow in the eternal darkness. It's the universe's most stubborn, most desperate attempt to keep a flicker of light alive. It's a testament to the fact that even in the face of ultimate death, reality finds a way to surprise us. If you're finding this cosmic journey into the deep future as mind-bending as I am, and you want to keep exploring the universe's most shocking secrets, make sure to hit that like button and subscribe. You won't want to miss what happens next. Now picture these utterly transformed cosmic remnants, no longer the majestic blazing infernos of our era, nor even the cooling embers of white dwarfs. After an incomprehensible stretch of cosmic time, these objects are no longer just dead stars. They have become something fundamentally alien, something that defies our very concept of what a star is. We call them iron stars. Imagine a sphere, perhaps the size of Earth, but so incredibly dense that a single teaspoon of its matter would weigh more than Mount Everest. This isn't just heavy. It's a quantum mechanical nightmare of compacted iron nuclei. The atoms are crushed together, their electrons stripped away, forming a degenerate gas. But the nuclei themselves are locked into a rigid crystalline lattice of pure iron-56. This is the heart of an iron star. But here's the crucial, mind-bending part. These stars don't burn in the traditional sense. There are no raging fusion fires like in our sun. The energy they emit isn't from explosive nuclear reactions. It comes from that agonizingly slow, improbable process of cold fusion, fueled by quantum tunneling. The light elements remaining in their cores are still converting into iron-56, but at a pace so glacial, it makes geological time look like a fleeting thought. The resulting glow is almost imperceptible. Think of it not as a beacon, but as a phantom whisper of light. If you were somehow able to observe one of these iron stars from even a short distance, it would appear as little more than a slightly warm, incredibly faint, reddish-purple ember against the absolute blackness of the void. It's the universe's last dying gasp of luminosity, a testament to the persistent, almost defiant nature of quantum mechanics. Their existence is a profound statement about the ultimate fate of matter. They represent the final stable configuration for many stars. Before the universe succumbs to its heat death, everything that can become iron will become iron. These are the ultimate cosmic factories, converting all available lighter nuclei into the most stable element, a process that continues for incomprehensible durations and their lifespan. Brace yourselves. While our sun lives for billions of years and red dwarfs for trillions, iron stars are predicted to persist for timescales that make even those numbers seem ridiculously small. We are talking about 10 to the power of 1/1500 years for their formation, and potentially far, far longer for their eventual decay. To put that in perspective, if the current age of the universe were 1 second, an iron star's lifespan would be longer than the entire history of the cosmos, repeated an unimaginable number of times. They are the universe's final islands of order, the last stubborn outposts of organized matter in a cosmos that has otherwise dissolved into a featureless, frozen expanse. For an epoch longer than the Big Bang has been expanding, these dense, cold, glowing spheres of iron will be the only sources of light, the only active processes of change in a universe otherwise dead and silent. They are the ultimate endurance runners of the cosmos, holding on to existence with a quantum mechanical grip. Imagine civilizations, if any could possibly survive for so long, looking out into this impossibly dark future. Their only light would come from these faint, distant iron stars, a melancholic reminder of a universe that once blazed with glory. These are not just theoretical objects. They are the ultimate expression of cosmic patience, the universe's final, desperate attempt to hold on to structure before the inevitable, absolute stillness descends. They are the last heartbeats of a dying cosmos, echoing through an almost infinite night. Even the universe's most stubborn embers must eventually fade. The iron stars, those impossibly dense, faintly glowing spheres, are the universe's final defiant stand against absolute stillness. But their reign, however unimaginably long, is not eternal. The relentless, patient march of entropy, combined with the bizarre rules of quantum mechanics, will eventually claim even these last outposts of light. The very process that forged them, quantum tunneling, will also be their undoing. Over timescales that make their formation time seem like a blink, the iron nuclei themselves will begin to quantum tunnel. But this time, it's not for fusion, it's for something far more profound, fission. Yes, the most stable element, iron-56, will, against all odds, spontaneously decay into lighter elements, or even eventually fuse into heavier ones, pushing past the iron peak. This process, driven by the same statistical improbability that created them, is agonizingly slow, releasing even less energy than their formation. It's the universe slowly, almost unwillingly, unmaking its own final creations. But the true ultimate fate of these iron stars is even more chilling. Given enough time, and when we speak of enough time in this context, we are talking about numbers so vast they transcend any human concept of duration. Numbers like 10 to the power of 1026 years, or even 10 to the power of 1076 years. Even the most stable matter will succumb to the relentless pull of gravity or the mysterious decay of fundamental particles. One potential end for an iron star is a process called quantum tunneling to a black hole. Think about it, a star made of solid iron, incredibly dense, but still held together by quantum degeneracy pressure. Over these unfathomable timescales, the entire star, as a single quantum entity, could spontaneously tunnel into a black hole. Not a violent collapse, not a supernova, but a silent, almost instantaneous disappearance. One moment, a faint reddish glow. The next, nothing but a ripple in space-time. A newly formed black hole, slowly beginning its own, even longer, journey towards Hawking radiation evaporation. These are the universe's final, most profound acts of self-consumption. Alternatively, if protons are not absolutely stable, and many theories predict they aren't, the iron stars would face an even more fundamental demise. If a proton can, over truly cosmic eons, perhaps 10 or 34 years or far, far longer, spontaneously decay into lighter particles like positrons and photons, then the very building blocks of matter would unravel. Imagine a star, not burning, not collapsing, but simply dissolving atom by atom, nucleon by nucleon, into a thin, featureless soup of radiation and fundamental particles. The iron star would literally evaporate, its mass transforming into fleeting energy, spreading out into the ever-expanding void. Regardless of the exact mechanism, the outcome is the same: the utter complete cessation of all organized matter. The last black holes will eventually evaporate, leaving behind only a faint shimmer of Hawking radiation. The last protons will decay. The universe will have expanded to such an unimaginable size that every particle, every photon, will be so far separated from every other that interaction becomes impossible. What remains is the ultimate stillness, a universe of absolute uniform cold. No stars, no planets, no black holes, no matter, no energy gradients, no information, just a vast, empty, featureless vacuum, drifting eternally at absolute zero. This is the heat death of the universe, the final curtain, the ultimate triumph of entropy. It is a state of perfect, unchanging equilibrium, where nothing can happen, nothing can exist, and nothing can change. The cosmic dance, which began with a fiery bang and continued through the eons with blazing stars and living worlds, finally ends in an eternal, profound silence. The universe in its entirety finally achieves a state of ultimate, irreversible, and terrifying peace. We've journeyed through the universe's epic saga, from its fiery birth to the unimaginable silent darkness of its ultimate end. We've seen stars blaze and die, watched as the cosmos held onto a desperate flicker of light for timescales that break the mind, only to finally succumb to the inevitable march of entropy. The story of iron stars isn't just a scientific prediction. It's a profound, melancholic poem about resilience and ultimate surrender. It forces us to confront the terrifying grandeur of cosmic time, the sheer crushing weight of infinity. Our own existence, our glorious sun, our entire galaxy are but fleeting blips in this incomprehensible narrative. Yet, in daring to peer into this chilling future, in tracing the quantum whispers that defy classical death, we perform one of humanity's most audacious acts. We seek to understand the very fabric of existence, even when it points to an end beyond all imagining. The universe will die, yes, but its death is a spectacle of such immense slow-motion power that it almost feels like another form of life, a cosmic process playing out across scales that make our entire history seem like a single, microscopic vibration. And in contemplating that, we find a strange, unsettling beauty, the beauty of a reality so vast, so patient, so utterly indifferent, yet so fundamentally governed by laws we can, against all odds, begin to decipher. Tell me what you liked or disliked about this video. What do you think could be changed to make it better? I read every comment and will respond to every suggestion.